Hello and welcome to the very first Extinct Motorsports Engineering video blog entry. Today we're going to talk about another common problem with the Land Rover Discovery 2, that being the tendency for the engine temperature to creep up as you're sitting idling in a drive-through line or a car pickup line, or perhaps even just driving rather slowly off-road climbing a steep grade. Any situation where there's just not much vehicle speed moving across the radiator to keep the engine cool. We're also going to talk about our new kit that we've engineered to help alleviate that problem, our dual electric radiator fan kit. We're going to talk about some of the alternatives we considered before engineering the kit. We'll talk about some of the shortcomings of the factory mechanical fan system, and then we'll talk about some of the benefits of the dual electric radiator fan kit, along with some of the finer engineering points of the kit. We'll finish up with some links to some installation videos, some photos on the website, and also where to find the kit on the website and how to order it.
So besides the poor design of the factory D2 thermostat, one of the biggest issues with the D2 cooling system is that the D2 is prone to running a little hotter than we like when idling or driving really slow in the summer with the AC blasting. You might see this sitting in your child's pickup line, or maybe a drive-through, or really maybe just a really bad traffic jam. The basic reason is that the D2 idle speed is just a little too slow to move enough air in coolant to allow it to keep the engine temperature in our ideal range when off-road. Again, because typically the engine speed is pretty low and the vehicle speed is pretty low, and sometimes, like when climbing a big hill, the engine load can be pretty high. So besides these two performance issues, there are some other negative characteristics to the factory mechanical fan system that can cause a D2 to run hotter than we would like when idling. One is fan clutch wear. Even though all these vehicles are 20 years old or older, many still have the fan clutch and fan that they left the factory with. And it's very common for the factory fan clutch to lose some engagement performance with age and miles. If that happens, your airflow through the radiator is going to be lower at the low speeds when you need it most. Lots of times you can't even get the factory fan clutch off of the water pump, and I haven't been able to get this one off of the factory fan. The clutch on this one's actually good, but as you can see, the fan's broken. Anyway, okay, so one of the things that we see frequently with Discovery 2 fans is they were made out of pretty brittle plastic, and I've got several. You can see I've outlined the defect or the damage. This entire blade is missing off of this fan. There's a giant hole in this one. I've got some others down here. This fan had pieces, lots of pieces missing from the fan blades. This is a frequent issue with D2 fans, and these have been known to completely explode and take out everything under hood, including your radiator shroud, your transmission cooler lines, your oil cooler lines, your radiator hoses, your T, your thermostat, your air box tube, all of it when this explodes. Because typically what happens is these get some sort of an imbalance once they've cracked. And this one's got a giant crack here, you can see. And so they get an imbalance, and usually when they explode is you're on an on-ramp and you're accelerating, and the engine goes up to 4,000 or 5,000 RPM, and the imbalance takes effect and the fan just comes completely apart. I actually had that happen on one of my Discos, which is, and it flew apart, took out everything under hood, and that's when I put the first dual electric radiator fan kit on, because I thought, I'll be damned if I'm going to have this happen again. At the time, my other vehicles, I had a Camaro SS. It had dual electric fans with a 5.7 liter, and it ran fine. So I just wanted to show you some of these typical type defects you'll see It's a good idea to inspect your fan if you've already got one and you want to stick with it, but I really recommend the dual electric because it eliminates the flying apart and destroying everything under hood possibility. Finally, the mechanical fan system gets in the way of servicing the front of the engine in a way that an electric fan does not. With the mechanical fan system, the first thing you have to do to replace an idler pulley or the power steering pump or the water pump is to remove the factory fan shroud and then the clutch fan. Many times, unless someone has been smart enough to put some never sees on the clutch fan mounting boss, getting the clutch fan nut off can be next to impossible. Some owners have had to cut the fan nut off so they can get the water pump replaced. Compare this with the electric installation where you can remove the factory fan shroud permanently, enabling you to easily get to everything without removing anything. Additionally, with the factory fan shroud, you can move the upper radiator hose such that you can move the inline thermostat installation away from the alternator pulley, thereby reducing the risk of the alternator pulley rubbing a hole in your upper
So in the
radiator
interest
hose.
of bringing a fair analysis to viewers on our dual electric solution, we did some comparisons with other popular alternatives.
So one of the alternatives to the factory fan is a heavier duty fan clutch and fan. The Ford Explorer fan is a popular retrofit on the Land Rover forums. We took a look at how this popular replacement compares to both the stock fan and our dual electric fan. Okay, this is our 52,000 mile, 2,000 year model Disco with all original parts, and you can see it's running about 15 miles an hour. Whew! Too hot to hold my hand there for very long. It's a hot day here in Virginia. It's 97. You can see we're running 110 across that radiator. Okay, so this is our Ford Explorer fan, our Discovery. You can see it runs about 20 miles an hour. Temperature is about 110 degrees coming through the radiator. Okay, so what we've got here is we're testing our electric fans. We've got a pretty hot day. Reading 96 degrees coming across the radiator. You can see the driver's side fan is reading about 22 miles an hour. And if we go over to the passenger side fan, we are reading about 18 miles an hour. So one of the other advantages, of course, of our dual electric fan is we can move the inline thermostat away from the alternator pulley. You can see here it doesn't impinge on it. And you can probably hear it's also quite a bit quieter than a normal engine-driven fan.
So you can see from that comparison, the Ford Explorer fan with clutch does indeed move more air than the factory fan, about 5 miles an hour difference at idle, and the electric fan basically equals or exceeds the Explorer fan airspeed. So we also compared how the factory, the Explorer, and dual electric fans compared on noise in the cab. For this test, we assumed most dual electrics would have a similar noise level.
Okay, so we're going to start our radiator fan decibel testing on our 2000 year model, 52,000 original miles stock Disco with the factory stock radiator fan. We've got the air conditioning running to load some heat into the fan so the clutch is engaged, and we're going to do all our testing at low speed because if you go very fast at all, it disturbs the decibel testing due to wind speed noise. But let's go ahead and get started testing, and then we'll see how it goes. Okay, so now all of our testing today is going to be done with the air conditioning off. You can see it's about 73 degrees today. The radio is off. I've got it set to sport mode. We're going to keep this relatively low speed. I'm going to basically accelerate with the engine at the torque converter slip, where it's going to come up to about 2100 RPM and stay there. So this is our spectrum analyzer we're going to use. You can see I've got my Dayton Audio calibrated microphone in the set in the analyzer in the cell phone, and we're going to do a first test in the full spectrum, and you'll see that most of the noise is in the 125 hertz to 250 hertz area. And then after that, we will change the spectrum and zoom in a little bit so we can focus only on that particular frequency and get a little bit better resolution. So let's go ahead and do our first test, and then we will see how it compares to the Explorer fan and clutch and the dual electric fan. Okay, here we go. And we're going to go from a dead stop. And you can see the maximum is about 61 hertz or thereabouts. So let's zoom in on our frequency analyzer and we'll get a little better resolution. So we're going to change our frequency resolution. And we're going to go from basically 500 hertz to about 50. Okay, now you can see we're zoomed in a lot so that we'll be able to do a higher resolution test. We're using the same decibel scale though, because it's not going to change much with the stock fan. We may have to increase the decibel scale a little bit with the Explorer fan. Okay, here's our zoomed in test, so you can get a little bit better look at what the frequency is, or what the decibel level is rather. Okay, that was that test. Now we'll switch to the other fan. Okay, so now we are testing the Ford Explorer fan and clutch, which some people on the forums use as a heavy-duty replacement for the factory stock one. So same test conditions, same day, just a few minutes later. It took me like 3 minutes to swap the fan out, and we'll show you how that compares with the with the factory fan. Okay. So again, the same test conditions. Everything's off. We'll turn our spectrum analyzer on. Let's see. Here we go. You can see the same thing, so let's have a look. And we'll zoom in a little bit here so we can get a good view of it. Okay, here we go. We're going to do the same RPM test. what you can see with that test is the Explorer fan is considerably louder than the factory fan. Okay, so the one test condition I forgot to tell everybody about was the engine operating temperature. This truck has a 170-degree thermostat in it, so it's sitting right at about 176. And so all our tests, you can see the mileage here, were done, you know, within a few hundred feet of each other, and that was the engine temperature. Okay, for our final noise test, we're going to test our dual electric radiator fan. You can see both fans are on running. We've turned them on manually. This is our 238,000 mile trail truck. It's got 285s and a 3-inch lift and a winch bumper and a bunch of other stuff, so it should be considerably louder than the factory fan. So let's see how it does. Now this is our fan control, and you can see fan 1 and fan 2 are blinking because we've got it manually turned on with our manual fan switch here. You can see this is our 238,000 mile truck. We have the shifter in the same position. The air conditioning controls are off. So let's see how it does on the noise level on our acceleration test. Okay, we're gonna zoom in a little bit so you can see it. All right, here we go. Okay, you can see it was considerably quieter than the Explorer fan, and about the same noise level as the
So you can see from that comparison that the Explorer
factory stock fan.
is approximately 4 times as loud as the factory fan, but the dual electric fan is not even as loud as the factory fan. Another popular alternative is aftermarket electric fans. Of course, no one makes an aftermarket kit with a custom shroud like this just for D2s. So then you are either custom fabricating your own shroud or mounting dual fans with a shroud only around the fan, thereby reducing airflow through the radiator by the fans. Of course, you have to think about pushers versus pullers, but really pullers are the best choice as the D2 already has one pusher fan. So there are lots of aftermarket fans out there, and I obviously can't test them all. But one of the OEM fans that has been retrofitted to the D2 by some of the forum members is the 2011 to 2013 Ford Fusion fan. So I thought I would compare the fan speed of that fan to the fan I engineered our kit to use, which is the fan off of a 1989 Nissan Maxima.
Okay, so the other thing we wanted to do was compare the Ford Fusion fan that's been mentioned on some of the forums to the Maxima fan. And so this is a brand new Ford Fusion fan I bought off of Amazon, and I've got it set so it fits the disco radiator. We're right up against the radiator. There's a little bit of the fan's got a lip on the shroud that fits well to the radiator on the bottom. This is the bottom, and you can see it does fit quite good on the side here. Okay, but we've got a little bit of an overlap, and it'll be difficult to see, but you can kind of see right here. I've got my finger, so there's about maybe a 1-inch overlap to the shroud here, and then there's a bit of an overlap here. I'm not going to cut this fan. You can see it's hitting my nipples right here, but if you were going to use this shroud, you could cut the shroud right here and it would fit the disco fan. So it's not a bad fit. Very similar to the radiator. I would say it's more or less equal. So now we'll go ahead and we'll do a fan speed test on the Fusion fan and show you the differences with the between the Fusion and the Maxima fan. with our same power setup. Now the Fusion fan, it's a dual fan, but it's a single speed, single motor winding, so there's not all the options that we have with the Maxima fan. But let's get it set up on our test rig, on our sawhorses, so we can do an airflow test. Okay, so this is our power supply set up for our fan test. What I've got here is two full-sized automotive batteries, and these are connected to an RV battery power supply conditioner charger. This is large enough, it puts out about 1,000 amps total at full power. But the idea here is we're going to keep this this unit connected to the batteries so that we have constant supply voltage throughout the test. And what you'll see over here where we're set up to do our test, you can see we've got 13.5 volts. This is our kit, basically the fuse panel and the bracket that comes with the kit, you can see. And what I've got is I've got the jumper cables, and I've got all the power wires connected to the positive jumper cable from our battery bank, and I've got all our negative wires connected to the negative jumper cable from our battery bank, and I've got my power leads in it. And then what we're going to use, of course, is we've got our trigger wires on our relays. These trigger wires go to our fuse panel, and in your disco, what you're going to use is you're going to connect those trigger wires to your choice of fan controller. This is the fan, this is the fuse panel bracket, and the fuse panel that comes with the kit. And so those trigger wires are going to connect to your controller, and they're going to trigger the relays, which are also part of the kit. You can see we've got the relays mounted right here to the fuse panel bracket. So they're going to connect to that. And then what I'm going to do for the testing is basically I'm going to take these jumper wires that I've got connected to the trigger wires. You see them here. And then I will connect them to the positive battery cable to start the fans. You see, like that. And that starts our fans up and runs the fans. So that's the setup that we're going to use for all of our testing. Okay, before we start with our fan speed test, a little bit about the fan that we recommend that it be used with the kit. So this is a fan off of a 1989 Nissan Maxima 3.0 V6. Okay, besides being a dual electric fan like a lot of cars have with, this one we selected for a couple of reasons. One is the fit to the radiator, and you'll see later in the video how the fit to the radiator is particularly good for the D2 fan. But the other one is the fans on this particular set are very interesting. Each fan motor has a dual set of windings, a high speed and a low speed set. You can tell that by the 4 wires going to the fan. So each one of these fan motors actually has a low speed and a high speed set of windings. And then when you combine them, what you get is an even higher speed. So we basically essentially have 4 different levels of fan speed that you can generate. Now, I'll demonstrate that in just a minute on this right fan. In addition to that, in addition to high speed and low speed on each fan, the right fan has a higher speed than the left fan. Now, most of your controllers that you would use are not going to have 4 different discrete levels of fan speed, and I'm not sure you would want 4 different levels of fan speed anyway. But this fan does have that capability. I typically use it where I just either turn one fan on and then the second fan on. So I've combined the 2 speeds. But there's lots of different fan controllers out there, and you can wire it any way you want. But just for a demonstration, the first thing we'll start with is the right fan, which is our high-speed fan, and we'll show with one winding on and then the other winding on, and then both windings on. So this is our gauge that we're going to use for measuring our fan speed. I've got it set to measure the temperature, and you can see that it's about 78 degrees, and I've got it set to miles per hour for measuring the speed. So the first thing I'm going to do is I'm going to connect the low side And what you can see is it runs about 22 and a half miles an hour. Okay, and now we're going to connect the high speed. And that runs about 23 and a half miles an hour. And now we're going to do both. You can hear it speed up. And now the fan's running about 26 miles an hour. Okay. Okay, that was just a demonstration of how the individual fan windings create different speeds on the fans. Now what we're going to do is we're going to compare the left fan to the right fan. I've got the leads basically twisted together, so we're going to get both fan motors. I think you really only are interested in what the top speed is. If you want to know what the individual speeds are, certainly you can test it yourself. But let's just see how left compares to right. So we will go ahead and start with our right. And we're running about 26 miles an hour on the right. Now let's do the left. And what you can see is the left runs about 19, maybe 20 miles an hour. Okay. Okay, we've got our fusion fan set up to do the test. I've got jumpers connected to the fan motor. You can see I've got the same 13.5 volt power supply that we used before, our two battery banks and our conditioner. So I'm going to go ahead and move the voltmeter out of the way, and then we'll test the left fan, and then we'll test the right fan. You can see I've got the orientation set up. These are the airflow flaps at the bottom of the fusion fan, and so that's the orientation we'll use with respect to left and right. So let me get this out of the way, and then we'll do the airflow test. Okay, so we've got our meter set to miles per hour. You can see it's about 69 degrees in here. And so let's get started. We're going to start by testing the left-hand most fan on our test rig. Let's see, let me get it angled so you can see the readout. Okay, I think we'll be able to see there. So let's go ahead and get the fan turned on and see what she runs. Okay, you can see she's running about 17 miles an hour, maybe about 18. And you can see that in the screen. Okay, so let's see what the other side does. Okay, here we go on the right side. You can see right side does about 19 miles an hour.
So now that we have discussed some of the issues with the factory engine-driven fan and some of the alternatives we considered when developing our kit, it seems like a good time to recap the key advantages of dual electric fans over the alternatives. 1. It helps alleviate the idle and low speed overheat problem by providing full speed airflow regardless of engine speed or vehicle speed. 2. There is the previously shown improvement in service access, since removal is not required to service the front of the engine and any accessories located there. 3. For the D2, which is prone to fan explosions of the OEM fan, There's no risk of fan explosion taking out your hoses and fan shroud and other accessories. 4. It's quieter than the engine-driven alternatives that eliminate the idle and low-speed overheat problem. 5. Another advantage is the ability to manually override for both turning them off, for example, for water crossings, as well as when you want to turn them on, perhaps to boost your cooling or your AC system. If you're running a fan controller similar to the one we recommend, then you could have complete independent control of both fans. 6. There's also faster warm-up in the winter due to minimal airflow across the radiator until the engine is up to temperature. 7. Slight increase in horsepower due to elimination of fan parasitic drag. 8. Increased air conditioning efficiency due to the increased airflow across the air conditioning condenser.
One of the biggest benefits of the dual electric fan is increased airflow over the engine-driven fan in low-speed situations. It's not just the airflow speed that increases airflow, but also the surface area. The factory fan or even the Explorer fan, they both have a diameter of about 18 inches. And the dual electric fan that we're using has a diameter of 13 inches. So the diameter of 18 inches gives you a surface area of 254 inches approximately. But the dual electrics having diameters of 13, but there's two of them. And that gives us a surface area of 265 square inches. So if we use our previous measured airflow speeds of 20 mile an hour for the Explorer fan and 18-ish for the factory fan, you see that with the Explorer fan, which is faster, you'll see the airflow works out to about just over 3,000 CFM. But the dual electric fan, where you'll see we're going to get 26 miles an hour out of it, that gives us just over 4,200 CFM for the dual electrics. That's 50% more airflow than the engine-driven fan. I'll leave the math in the comments for you guys who want to check my math on that. So one of the advantages of dual electric fans, and the major reason almost all manufacturers are going to them, is that there is no parasitic drag when they are not needed, like on the highway. Here you can see we are driving at highway speed and our fan controller does not show that either fan is running, because right now we don't need the fans.
So now that we've gone over the factory engine-driven fan limitations, shown you a comparison of dual electrics to some of the alternatives, and gone over the top 10 reasons why a dual electric fan is a better choice than an engine-driven fan, I thought it would be a good idea to go through some of the finer points of the engineering of our kit for the D2.
Okay, so now I'm going to talk a little bit about engineering our wire harness for the kit. So the first thing we wanted to do is we wanted to make sure it was plug and play as much as possible. So the connectors on the end of the wires that are intended to go to the dual electric radiator fan assembly, they're the correct connectors. So all you need to do is plug them in. We also wanted to bias towards safety. We wanted to make sure that customers did not have any issues with the wires being undersized. We probably went a little overboard on that. All the wires are oversized 12 gauge wires, all the way out to the connectors, the ground wires included, as well as the power feeder wires. And we had one power feeder wire for each fan winding. As we explained in the video, the recommended dual electric fan is a dual winding fan. So we have one power wire for each fan winding. The colors are all coordinated. Not a big deal here, as I said, because it's all plug and play. Now what I've done here is I've gone ahead and I've assembled the included fuse panel to our included bracket and the relays to the bracket. All this comes disassembled, but we include the screws, and it's designed so that you screw the relays directly to the bracket and you screw the fuse panel directly to the bracket, and it all fits. You'll see it on the truck when we install it. It all fits really nicely. Now the fuse panel is an 8-position fuse panel. We have 40-amp fuses for the main power wires going to the fans, and we have 10-amp fuses for the trigger wires that trigger the relays. Okay, so each one's got their own, and you can see them all here. Right now, these are the trigger wires. This is the actual harness that we use in our test video. You can see the trigger wires. I have twisted them together just for the purposes of the test and to show you here. These would connect to whatever fan controller you're going to use. It could be a single or dual rocker switch. It might be the recommended Craig Davies controller that we recommend. Could be something else. We also have a single ground wire for all the relay trigger wires. This is separate as well. Now you'll notice our main ground wire and our main power wires. Right now we've got the bolts that we used in our fan test connected to them. But what you would do is these, of course, will connect to the main lugs on your battery, and this, of course, will connect to your main lugs on your ground post near the underhood fuse box. The final thing to mention about the wire harness is all of the ends were terminated, soldered, and heat shrink tubing over the ends to keep them um, basically protected. And then we used heavy duty terminals on the end so that they can withstand a little bit of rough handling under hood, some bending and such without breaking. So that's our custom designed wire harness. Of course, the fuse panel has a cover, goes right over it like that. And you'll see in the installation video where all of this mounts. So the basics of the kit beyond the wiring harness and the fuse panel bracket are the brackets for installing the dual electric fan to the radiator. It's quite simple. There are 2 brackets that install in the factory radiator in the factory slots in the radiator. So the aluminum bracket we've designed slips into these slots, and there's 2 tabs that expand out, that you bend out to retain the bracket to the radiator. And then, of course, there's one for each. There's one for the top and one for the bottom. And then, of course, we supply some screws to fasten the 1989 Nissan Maxima dual electric fan to the brackets. For installation, it's pretty quick and
The
easy.
last piece of
We have separate
installing a dual
installation
electric fan is
how-to
deciding on
video
a fan
link in the
controller.
comments.
There's a huge variety of options to choose from, everything from a manual rocker switch to sophisticated programmable control boxes. Here you can see some various options in terms of fan controllers. I will put some links in the comments. I initially ran a manual controller similar to this unit from Flexolite, but that unit had too much of a deadband, causing it to either come on too early or too late. So I did some research and eventually settled on this integrated controller gauge system from Davies Craig. I know that seems to be a weird name, but that is the way they say it when you call tech support. Anyway, this unit offers programmable set points for turning on the fan, programmable alarm set points where it starts beeping and blinking, and manual override control for both turning fans on for extra cooling and off for things like water crossings. This video is already a little long, so I won't show you all of how this controller works, but there are plenty of videos on their website. So the final question with an external fan controller is, where does the controller get the engine temperature from? The answer to that question depends on the selection of the controller and what type of sensor it uses. But the main reason I wanted to mention it is because the inline thermostat configured with the port up provides a convenient place to install a fan controller sensor. I'll close out this video by going over how to find the kit on our website and talk a little bit about how to purchase the needed radiator fan and fan controller. So in the short term, the radiator fan kit and the complementary gauge pod for housing the fan controller gauge we recommend will be in the featured product category on the website. So the easiest way to find them is just scroll down the page so you can see the products. Longer term, you can click shop and then either select the vehicle designation, with the D2 being the case, or select the area with the fan kit in the underhood kits area and the gauge pod in the interior area. So as far as the radiator fan and the fan controller go, I'm sure people will ask why they can't buy those on our website as well. The reason is different for each. For the radiator fan, there are lots of retailers selling OEM replacement fans, and we could not possibly compete with their prices due to their massive volume. Amazon is likely the lowest cost place to get the correct radiator fan. As far as the fan controllers, there's such a huge variety of fan controllers, we could not possibly stock all of them at a competitive price to say Summit Racing or Amazon. We did contact Davies Craig about stocking their controller, but their minimum purchase requirements were larger than our annual total sales. So again, it makes more sense for customers to buy from their favorite retailer. A quick internet search will turn up several internet retailers selling fan controllers at a competitive price. I hope you have enjoyed this discussion on the use of dual electric fans to upgrade engine cooling on a D2. Of course, the concepts and practices discussed here would equally apply to most any vehicle with an engine-driven cooling fan. Who knows, if there's enough interest, perhaps we'll engineer kits for D1s, P38s, Range Rover Classics, Defenders, and who knows what else. Please be sure to let us know if you have any questions or comments, either in the comments below, or you can always contact us via email or the contact form on the website.